And so you've probably seen this equation before. You've probably plugged it into the quadratic equation because you can't factor it. And so what's interesting about this algebra equation is it represents the golden ratio. So the golden ratio is represented by the symbol phi. It's a Greek letter. You see it on fraternity shirts and stuff like that. The number phi is an infinite number, kind of like the number pi, 1.618, and it keeps going forever. It's the same number related to the proportions of the Fibonacci spiral, or the golden spiral, of a golden rectangle, which when you make a square cuts into another rectangle of the same proportion, and you keep doing that, and eventually inside of it you can make that golden spiral we're talking about. So you keep cutting a square out of the rectangle you have, and eventually you could start to draw that spiral shape. Surprisingly, it's also in a few other places. We see it in a pentagon. I personally think, even though that's not what they say, that the number 5 may come from phi, because the number phi, or the golden ratio, is built into a regular pentagon. This red side divided by the blue side gives us the same phi proportion. What other places do we see it in? The spiral, the rectangle, the 5-sided shape. We use it in photography. We have it in the bones and other places. So let's take a look at that. Buddy, I'm just excited to share a lot of the connections I've made in the last couple of years in geometry, and some of the things we talk about a lot, the spiral, the golden spiral. But I want to take a look at the algebra behind it. We'll look at different aspects of the golden ratio, the golden spiral, how the number phi comes from the spiral and the proportions. And we could also take a look at how it works in photography. But really the main point here is also to show the algebra behind it. So I never really knew this algebra function we probably solved before has actually been a number that represents, or that solves for, the number phi, for the golden number. It's related to that spiral and that golden rectangle you can make the spiral out of. And so the number phi is a number 1.618, and it goes on forever. It's represented by this symbol, and it's Greek, the Greek symbol for phi. You even see that in fraternities. And so we're going to show how when we solve that, we get this number, phi, at the golden number, as well as the negative reciprocal of it. Let's take a look at a few different things, though. First, this is the golden spiral, they call it. You see it a lot in nature and things growing. Like I was in my mom's garden, and they had zucchini with the branches would spiral out and grab onto things. So if you take a look, it's in a rectangle. And we'll talk about that. It's called the golden rectangle. It's these proportions that really can help us to draw the golden spiral. So we see it in nature, and we see it in a lot of different places. The proportions of your ear and your fingers, and in the sunflower seeds and pineapples and pine cones, snail shells, and in a lot of ways. I made a video about the spiral you could check out. You could spend your whole life learning geometry. I learn so much every year. Algebra is really the language that helps us to manipulate and understand geometry better. Geometry is the study of how things work and the measurement of things. So I know that's biased, but so taking a look at all of these different places we see it, there's a video I made on both the symbolism and math behind it, but really it gives balance and it gives strength. So it's a structure that also has a purpose, and it creates this nurturing balance, allowing things to grow in the way that's good for them. So, you often see little posters with things like a snail shell and the galaxy, a storm that's the size of our eastern United States. So you see the proportions in different places. I like to see that in the garden oftentimes. And you see it in an octopus and, a goose's neck, because again, what it's doing is gaining momentum. It's also, what it's doing is it's creating an efficiency, so things get moving. Now, it's efficient for what's happening, but it's not always good for us. So when a storm is happening, the weather of the cold and warm front, when things hit, just sort of like water going down the drain, as when the cold and the warm hit each other and start to mix, the most efficient way for it to happen is in that spiral, and it creates kind of like a wave in the ocean, this momentum and force. And so it's good for the storm, makes it more powerful. It's bad for us, as as it creates destruction and even death sometimes. We see it in the galaxy and the Milky Way as well, because things are spiraling and circling around, and they tend to fall into sort of order in the spiral pattern. We'll talk about the golden rectangle in a moment when I get to the note-taking thing, but you could take a look here. You could put a rectangle, and what happens is you can make a square out of it, and it creates another rectangle of the same proportion. But this is a bad picture. It's cut off. We'll take a look. But this represents a storm, and pretty much every hurricane coming in has that. But this allows the weather people to sort of predict the pattern of where the weather will hit. Now, sometimes it changes, but again, it's sort of like the weather is the cold and the hot, like when the air hits smoke and it starts to swirl, and that swirling has so much sort of movement and force behind it, it gets stronger and stronger and creates a more powerful storm front. You often see in the human body, the proportions, we'll talk about that number 5, 1.618. So when you divide the proportions of the sides, it gives you that number. You see it in your hand. So the bones in your hand have that Fibonacci number. Those of you familiar, there's lots of videos about that. It'll have 1, 1, and 2. 2 plus 1 is 3. And even your arm will have those proportions we saw. So it's something that, Da Vinci studied in his notebooks. Like I said, it's an infinite number, sort of like the number pi. Pi is an actual thing. It's the circumference divided by the diameter, so it's like the pizza crust divided by how far it is across the pizza, the diameter. And that gives you the number pi. That's infinite, so you can draw it, but it's a number you can't finish writing down. And of course, we use it in photography. It sort of makes things balance and gives you a focus of where you're looking. So because it's 1.61, it's about 2/3. So in photography, they call it the rule of thirds. You'll see an option to turn on this grid in your cell phone, and then it allows you to kind of see 1.618 is about right here. And there are other ways to use it to give you a focus of where your eye goes, sort of like in the mountain. So let's take a look at the math and the algebra behind it and sort of connect the two. And then we'll talk about solving that. So we did talk about photography. So the golden rectangle is kind of a way we can draw the spiral. And the idea of it is, if you take this rectangle, now I'm estimating because I'm not using a compass or a ruler, but we'd like to cut a square out of it, right? So in a square, the sides are equal. And when you do that, it creates this rectangle here. I'll make it blue. And this rectangle is going to be similar, the same proportions as the original one. So we're going to cut a square out of that one, right? And we can see it makes another rectangle, and it would, if I did it correctly, it would be the same proportions of the original. So then I would cut that one into a square, and again have a rectangle here. That would be the proportions that are similar to the original. Cut that into a square, and so we keep going on with that game, and you just use a quarter of a circle, an arc. Oh, this is a terrible one. And you use a quarter of a circle here, 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 and it begins to spiral into that pattern we would call the Fibonacci spiral. And again, it kind of even reminds you of a snail shell. So that's that rectangle where it's like a pattern of a rectangle and a rectangle and a rectangle that we can create a spiral out of. So if we measured that amount, this piece divided by this piece would be 1.618. So it's sort of a measurement, like the radical 2 is a number that goes on forever, like we had mentioned the number pi does, right? But all it really is if you take a square and you have the sides 1, the diagonal is radical 2. So it's just that side in blue compared to the green side gives you radical 2, which is a number you can't write down, but it's a shape that we can draw. And so we can't really finish writing down the number phi, but we can draw the shape representing it. So it's not only in a rectangle, it's in other shapes as well. So when you take a pentagon that has equal sides, we call that regular. From here to here, divided by any of the sides, those proportions will also give you phi, the golden ratio. So you can get the golden ratio. So the number that's kind of related to the spiral is a proportion that the pentagon has. Now, if we make it into a pentagram, what we end up with is another place where we see the number phi. This blue side divided by this side, so we see that in different places, right? Like here, divided by this piece. Those will also give you the proportions of phi, or the golden number. So maybe that's why we see a lot of flowers. I have a video on that, on the flowers that I see in my walks that have the number of leaves that are on the Fibonacci's numbered pattern, right? So we could look that up, but it's how we get even the number of squares in that shape we just drew in the rectangle. It's called the Fibonacci number, but I don't want to get into that. But we just keep adding these two, the previous two. 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5. When we keep adding the previous two, what we end up with is the same proportions we would get in that golden rectangle. And so as we continue this and divide, we would get the number 5. We divide backwards, but that's much different. We would need a few minutes to discuss and go into that. So go ahead and look up, if you're interested, the Fibonacci number, but it's related to this same spiral shape, and this number we're talking about, phi. So let's talk about how we can get that from this equation. What we know about the quadratic equation is that the number in front of the x squared, in this case there's no number, it would be 1x squared, one of them. It's the a, and the position of the number in front of the x here would be 1, that would be the b, and the c would be the number -1. So we're going to plug that into the equation. We're going to say negative of the -1, the b value, plus or minus square root of b squared, so -1 is what b is, so -1 squared, minus 4 times the a value, which is 1, times the c value, which is -1. And all of it over 2 times the a value. So again, you should be familiar with the quadratic equation here, and so what you end up with here is -1 times -1 is 1, plus or minus square root of -1 times -1 becomes +1, -4 times 1 is -4, times -1 is +4, all of it over 2. So our final equation here is 1 plus or minus the value of radical 5 all over 2. So let's take a look at that number. 1 plus or minus radical 5, all of it over 2, can be written in another way, right? We can separate them 1/2 plus or minus radical 5 over 2. And when we plug that into the calculator, let's see what we get. 1 plus radical 5 equals this divided by 2. We get 1.61803. Let's plug in the other one and see what value we get. So it's going to be the negative reciprocal of phi. Let's take 1 minus 5 radical 5 over 2. So 1 minus 5 and then radical button divided by 2. We get negative 0.61803. So that's our other answer. So that is the number we use as the golden ratio and its negative reciprocal. So if we thought of it as slope, right? If we had this slope, the perpendicular or negative reciprocal would be this number here. So that is where we get the value for phi, the symbol we use here. And so again, we get the spiral from this, we get the golden rectangle from this, pentagons have this proportion in it, and so it's comparing one side to another, sort of like the diagonal of a square. Like we got the neighbor's dog, but what we have here are the value phi and negative 1 over phi. So again, that number is related to the rectangle, the pentagon, the spiral, and other things we see that create balance, momentum, and efficiency. Phi and the negative reciprocal of phi, and you see those in many different places in the proportions we see in our hand, in the galaxies, in a storm, in a wave, in the ocean. We see it in the garden, all over the place. It's a way to have efficiency, balance, and a way to help things grow in a way that's good for them. So having looked at the math and the shapes behind the golden ratio and that special polynomial, let's take a look at x squared minus x minus 1 equals 0 on the graph, and we're going to see the answers or the roots will be phi and the negative reciprocal of phi. Remember those numbers, 1.61803 and negative 61803. Let's take a look at GeoGebra software online. The proportions of many things we see in nature, it creates balance, it creates efficiency, as well as, in photography, as well as in pentagons and rectangles. So we do see that number in different places, and it's amazing that we can solve and manipulate using algebra and plug in for x to find an answer for those proportions. So that is how the quadratic equation can be used to solve x squared minus x minus 1. I would call that a golden polynomial, because when we solve it we get the golden ratio phi as well as the reciprocal of phi. And again, those represent those shapes that we enjoy. Oops, that's supposed to be a pentagon. Hopefully that made you at least interested in looking up some of those things, the golden rectangle, the golden spiral or Fibonacci spiral in photography, Fibonacci spiral in your body or in nature, or even to make you appreciate a little bit more about what the quadratic equation can do, and what that specific equation, x squared minus x minus 1, actually is all about. Squared minus x minus 1 into GeoGebra, what do you think we get? Well, most of you might predict we're going to get a parabola pointing upwards, like the direction of a basketball, but upside down. And where do you think the roots will be, where it's crossing the x-axis? I'll give you a hint. We've been talking about it. So here's what it looks like. It's a parabola curving upwards, and the roots, when you solve for the roots of the parabola, what you're getting are the two spots they touch the x-axis. And where do they cross here? At 1.618, phi, or the golden ratio, as well as negative 0.618, the negative reciprocal or negative inverse, sorry I couldn't say reciprocal, of phi. And so we've covered pretty much a few dimensions, maybe there are more. The shapes that include phi that I know of, I'm sure there are more, as well as the proportions we see that number in, as well as the graph or polynomial that contains the roots of the golden ratio and its negative inverse. So hopefully if you made it this far, you have a better understanding that will probably take you even further in math than I've ever been able to go. I'm curious to see what you all teach me. The golden rectangle in this shape here. Well, if we go from here to here, and we go down to the vertex, this point here, of course if we use a compass and straight edge, we would have a golden rectangle. So I sort of didn't realize that until I finished the video. So it's sometimes fun to discover things when oftentimes you necessarily didn't learn them on your own. So here's the golden rectangle inside of the polynomial that contains the golden spiral and the golden ratio and the golden number we would call phi, the root phi and the negative inverse of phi. Pretty neat to me. Lots of connections. They all fit together. So I will put this link in the chat as well as how to make the Fibonacci spiral, the pentagon, and any other videos that may be related. Hopefully this made some connections for some of you, because it was over the last few years some of the connections I made.